Well, when I found out I won the career award, I knew I had been nominated, so I was hopeful, but to actually win it was still a bit of a surprise and a shock. My grandfather came to this country to study engineering, so I knew a little bit more maybe than the average kid about what an engineer does. He was actually a civil engineer and a chemist, so I was always very interested in science. But then through participating in a number of outreach programs as a high school student and going to camps for women who were interested in engineering, participating in the Science and Engineering Apprenticeship Program, which is sponsored by the Navy, I was fortunate to get some hands-on experience and find out that engineering was really the path I wanted to take. We call it the nano to macro group. And we call it that because what we really do is we treat nanomaterials. They're basically like itty-bitty cylinders, so like itty-bitty straws, and we treat them like building blocks. So just like you have maybe Legos that come in a box and they're not configured the way you want to build them, first we have to take them apart and separate them and overcome the attractive forces, and then we try and rebuild them the way we want into larger scale objects. So we work with a variety of what we call nanocylinders, including carbon nanotubes, which are the strongest known material, silver nanowires, which are antimicrobial and electrically conducting, and then we use different tools to disperse them and separate them from each other and then order them back together into films or fibers or other things for various applications such as antimicrobial films or sensors or potentially high-strength materials. By 2015, over 15% of global products will contain nanomaterials or be nanotechnology enabled. Now what we do, of course, is just a small part of that, but you can already find carbon nanotubes, for instance, in sporting goods. What we're looking at is, in the 20th century they said the future was plastics. Well, now the future is these nanomaterials. So what we're trying to do is develop processing and characterization methodologies that could be applied to a broad range of applications, just like understanding how polymers could be characterized and how polymers could be processed led to all the many polymer applications we see around us every day. For the short term, we're going to continue what we're doing, but we hope to both see more of what we work on in terms of the basic research, eventually develop into applications, for example, surfaces that may reduce the spread of disease by being naturally antimicrobial, or materials that can make vehicles lighter and therefore more fuel efficient, or a new way to organize nanowires into electronic devices for the electronics industry. And also I think that I get a lot of satisfaction about seeing students progress and go on in science and engineering and start their own careers.